Okay guys, I'm going to just do a little video to talk you through question 7 from the mock because I thought it was quite a tough one. Not many people got part B. So we'll see how this goes. So first of all, we start off with this probability distribution and you're asked to show that B is 0.3 minus A. I'm not going to go through that because it's pretty simple. You just need to say that these numbers need to equal 1. So the sum of the probabilities is 1, so you add them up, you get 1. So B equals 0.3 minus A, as required. Now, finding the difference between the greatest possible expected value and the least possible expected value. This is a tough one because we've only ever really been asked in the past to find the expected value. So we need to start thinking about the expected value like it's a optimization problem. So can we graph it? So just to start off with, I just start with the definition of the expectation of x. It's each of these probabilities multiplied by, the value of x multiplied by the probability added together. So we end up with this, it's just multiplying those. Simplify it all down and substitute in for b because we've got b in terms of a from part A. And you get all the way down and you end up with the expectation of x is minus a squared plus 0.1a plus 2.2, which is a quadratic. So if you were given something like y equals minus x squared plus 0.1x plus 2.2, and you were asked to find the greatest possible value of y and the least possible value of y, you'd probably think about graphing it. So some sort of upside down parabola because it's a quadratic equation. The difference here is that we don't have the entire domain for x. So x here is like our a and our y is like e of x. So we need to think about what domain of a is actually possible. And this is where we're going between probability and functions, and we need to be able to figure out both together. So what's our domain for a? Well, a is a probability, so we know that a has to be bigger than 0. Well, bigger than or equal to 0, okay, because probabilities always have to be between 1 and 0. We've got the same on b, which is this, so we also have that 0.3 minus a is between 1 and 0. So a is between, let me just figure this out, and actually this should have been between 1 and 0 as well. So here I've got minus a is less than or equal to minus 0.3 and 0.7, and then multiply everything through by minus 1, I get this. Okay, remember to flip the inequality when you multiply through. So these combined, I know that a is less than 1, it's bigger than 0, it's also less than 0.3. I get this domain for a, which is that a has to be less than 0.3 but bigger than 0. So this is my kind of final domain. So when I look at the graph, I really only want to look between 0 and 0.3. Now I'll put this into my calculator and have a look at what it actually looks like.